Welcome! This is Raina Fitzgerald, and in this lesson we're going to add and subtract rational expressions that have common denominators. Here we're looking at addition and subtraction of rational expressions. In this first problem, we're adding two rational expressions. We can see that they have a common denominator, x minus 4. When we have a common denominator, we can add the numerators together, 3 plus x plus 8, and keep the common denominator. And this becomes x plus 3 plus 8 is 11 over x minus 4. And this is the answer to our sum. Here in this example, I'd like to show you what to be careful of. What I have here is a rational expression where I have a polynomial in the numerator and the product of three polynomials in the denominator, a monomial times a binomial times a binomial. Now, let's just take a look at what each one of these are. This 2x cubed, that's a term. Remember, we add terms. So 2x cubed is a term, and 5x squared is a term, and 3 is also a term. In the denominator, we have facts. We multiply facts. So 2x plus 3, that binomial is a fact. And x plus 1 is a fact. And 2x cubed is a fact. So in the numerator, I have the sum of three terms. And in the denominator, I have the product of three facts. Okay, let's move this up. What I want you to be careful of is I want you to cancel out only facts. So only facts can be canceled. So let's put a little box around facts so that we know that if we have nothing but facts in the numerator and the denominator, we can cancel those out. Those cancel out. Facts between the numerator and the denominator. Terms do not cancel out. So let's put a box around that. Terms do not cancel out. So terms do not cancel. So we cannot cancel out the 2x cubed in the numerator and the 2x cubed in the denominator because looking at the numerator, it's a term. Now if the denominator were also a term, let's say this was 2x cubed and I added this product of binomials, still the 2x cubed and the 2x cubed in the numerator and denominator would not cancel out because terms never cancel out. If we want to find out if we can simplify our expression so that facts cancel, we need to factor both the numerator and the denominator, and in this particular case, our numerator is not factored, or is not fully factored. Actually, I missed an x here. There should be an x right here. Okay, so let's factor the numerator. The greatest common factor in the numerator is in fact an x, so I'm going to start over here. I don't have a lot of room to work, and normally I work down, but we're going to work left to right and down. So if I factor an x out of the numerator, I end up with a 2x squared plus 5x plus 3. And let's write the denominator in there. Okay, there's our denominator. And this is equal to, okay, so right away what I see now is I have a fact in the numerator and a fact in the denominator. This x is being multiplied by this quadratic trinomial. I have an x down here too. So the x in the numerator cancels out with one of the x's in the denominator. It's going to make that a 2x squared. Okay, so now on the denominator I have a 2x squared, because I canceled out one of those x's because they're facts, times x plus 1 times 2x plus 3. Now in the numerator, that's the denominator. In the numerator I have, the x is gone, but in the numerator what I have is this quadratic trinomial, which I now need to factor. So to factor that, what we're going to do is, we notice it's of the form ax squared plus bx plus c, where a is not equal to 1. So let's work that out. We need to find two numbers, and I'll do that over here. We need to find two numbers, m and n, such that if we add them together, we'll get b, and m times n, such that if we multiply them, we'll get a times c. b is 5, so we want to add two numbers and get a 5. I'll put a line. These are the lines. We're going to put the numbers above the line. We're going to multiply two numbers and get an a times c, which is 2 times 3, which is 6. And I hope you can see that if we add a 2 plus a 3, we get 5. And if we multiply 2 times 3, we're going to get 6. So we've started our factoring right here. This starts our factoring for us, and what we want to do is we want to split the middle term of our original quadratic trinomial. So we're going to start with saying 2x squared, and instead of writing 5x, we're going to split it into 2x, this is from my m and n, plus 3 times x plus 3. Now 2x plus 3x is 5x, and we took this 5x and split it into 2x plus 3x, and that came from our m and our n. Now once we do that, we want to group the first two terms together, so let's do that. In the numerator, I want to group together the 2x squared plus 2x. And now I'm going to group together the 3x plus 3. Again, I have in the denominator, in the denominator have 2x squared and an x plus 1 and a 2x plus 3. We can't forget that they're still there. Now what I want to do here is I want to take my first binomial in the numerator. It's a sum of two binomials. In the first binomial, I'm going to factor out the 2 and the x. And what's left behind is an x plus 1. And don't forget that there's a plus between them, because we're not multiplying these binomials, we're adding them. We're doing factor by grouping right now. And now between 3x and plus 3, we'll factor out a 3. And what's left is an x plus 1. We have a bit of busy work where we have to keep writing this denominator in. 2x squared times x plus 1 times 2x plus 3. Okay, now if anyone's looking at this and thinks, oh look, there's a 2 in the denominator and a 2 in the numerator, I can cancel those out. I can cancel out this x and that x, or one of the x's from this x squared. We can't do that. In the denominator, I do have the product of all facts. But in the numerator, I have the sum of two facts and two facts. Okay, so in order to cancel out, everything in the numerator and denominator must be multiplication and facts. So that can't be canceled out. Let's finish factoring the numerator. And what I want to do is, I notice in the numerator is that I have right here the product of two facts, which actually this is a term. because it's added to the product of these two facts, which is also a term. So these two are both terms. This is somewhat, you can think of this almost as a binomial, where I have this entire entity is a term, and it's added to this entity. So I want to know what is the greatest common fact between these two terms, and you hopefully can see that it's the binomial x plus 1. So I'm going to factor out the binomial x plus 1. And when I do that, what's left? Well, in the first term, a 2x is left, because we can see this 2x right here, because we pulled out the x plus 1 and a 2x is left. And when we factor out the x plus 1 here, a 3 is left. So we say plus 3. And there's the numerator fully factored. Let's write in the denominator. So there's our denominator. And here now, if you look at this, the numerator is the product of two facts, x plus 1 times 2x plus 3. And the denominator is also the product of three facts. 2x squared is multiplied by x plus 1, which is multiplied by 2x plus 3. Now we can cancel out facts. And so we're going to cancel out the x plus 1 in the numerator with the x plus 1 in the denominator, the 2x plus 3 in the numerator with the 2x plus 3 in the denominator. And what we get for an answer here is 1 over 2x squared. Let's box our answer. And there we have it. So let's just summarize here to say that we want to be careful to only cancel facts. Here we have another example of adding two rational expressions. Notice that they have the same denominator. So their common denominator is x plus 3. Let's add them up. So let me move this up a little bit. The denominator will be x plus 3, and the numerator will be, first we have a 2x squared plus 7 plus 6x minus 7. Notice that the 7 plus 7 and plus a negative 7 are additive inverses, so they cancel out. Now in the numerator we have 2x squared plus 6x over x plus 3. Now we're not finished yet because we want to see if we can reduce this ratio. So let's move these up. And the way we can tell is by factoring the numerator and the denominator. In this case, the numerator is fully factored, but not the denominator. I can see that I have a 2x squared and a 6x. What's the greatest common factor? 2 and 6 is 2 times 3, so this definitely, they both have a 2 fact, and they both have a fact of x. So let's factor out 2x from the numerator. And we have 2x times x plus 3. That's our numerator. And we can see that 2x times x is 2x squared, and 2x times 3 is 6x. So now let's write our denominator. Our denominator is x plus 3. And here we can see that the x plus 3's, they're binomials, and they can cancel out. Move this over. So our final answer, what's left, is 2x over 1, or simply 2x. And I should probably put equal sign here so we see that we're moving down as we simplify the expression. Our work is down, and we can see that our original sum of two rational expressions is equal to 2x. Here's another example. Notice there is a common denominator, x plus 5 times x minus 2. They both have the same denominator. So right away, we can, let's move this up a little bit. There we go. We can immediately combine them into one fraction where we have x squared plus 2x minus 2, and that's really plus a negative 2, plus 5x plus 12, and then in the denominator we have the facts x plus 5 multiplied by x minus 2. So the numerator is the sum of terms, and the denominator is a product of facts. Now let's combine like terms in the numerator, and when we do, we notice that we have one x squared term, let's write this up here, plus, and let's see, we have two linear terms, 2 times x and 5 times x. And 2 plus 5 is 7, so we have 7x, that's our linear term. So this first term is our quadratic term, this is our linear term, plus, and we have two constant terms. We have a negative 2 and a 12, and if we add negative 2 to 12, we get a positive 10. So there's our numerator. And our denominator, again, stays the same. It's factored. When you're writing your answer, your final solution to a problem, it really doesn't matter unless you're specifically asked. It doesn't matter if it's a product of facts or a sum of terms. But what we want to do, because we are trying to simplify this, okay, what we want to do, since as we're moving through the process, we are trying to simplify, and when we simplify, what we're trying to do is we want to factor the numerator and the denominator because facts will cancel out. That's how we simplify. In the end, it doesn't really matter if you present it as facts or terms, but the reason that we try to get facts is so that we can see if anything will cancel out to simplify. Now, if we look at the numerator, we want to factor that because, again, we're looking for canceling. And this numerator, I can see it's of the form ax squared plus bx plus c, where a is 1. So we want to find two numbers whose sum is b, which is 7, whose product is c, which is 10. And if you think about it, if we factor 10, 10 is equal to 1 times 10 or 2 times 5. And there we see it. 1 plus 10 is 11, but 2 plus 5 is 7. So that's what we're looking for. We're looking for 2 and 5. 2 plus 5 is 7, and 2 times 5 is 10. So that's what we need. That's our m and n. So the numerator factors into x plus 2, that's our m and n, times x plus the 5 from our n. And here we can see what's going on here. I hope you can. Look at the denominator. The denominator is x plus 5. O times x minus 2, not plus 2. Okay. So what's going to cancel out here? The x plus 5s are going to cancel out. And our solution is x plus 2 in the numerator and x minus 2 in the denominator. So what I have are, the solution is the numerator and the denominator are linear binomials. They're polynomials which are both linear binomials. This is my rational expression that's simplified from the original, where I added up two rational expressions and I simplified by making sure both the numerator and the denominator were fully factored, and then I was able to cancel out the x plus 5, and there's my answer.